8 for CO2, which should tell you, or start to tell you, if you are correct. I'm going to fill in one more thing here.
Let's see if I'm right. I am right.
Are you
No,
correct?
I'm not right. I thought I was right. I was wrong.
I'm not.
Nope.
Yeah, I don't know.
Just the O2
I
thing.
just don't know.
I just don't
I
have
just
that,
don't know. It just happened.
Okay, so let me show you the pattern.
Oh,
It's double.
I do see
Okay, the evens have a different pattern than the odds, so that's a little tricky. The coefficient for carbon, for the CO2, is always either, well, the coefficient for the hydrocarbon times the subscript equals the coefficient for CO2. So 1 times 1 equals 1. 2 times 2 equals 4. 1 times 3 equals 3. 2 times 4 equals 8. So that's how you get that. And the coefficient for water is the coefficient for water times the subscript on hydrogen is always going to equal the subscript over here. So 2 times 2, 4. 6 times 2, oh, or, yeah, I'm sorry.
That'd be 12.
Yeah, so there we go. It's a little, yeah, okay. I missed that one. But it's, once you know how to do that, it took me years to be fast at those, but it's a handy thing. So what do you notice in terms of the volume or the number of moles of carbon dioxide produced as we go up in hydrocarbon chains? Compare the relative number of moles of carbon dioxide produced from burning methane, our good old cow fart, all the way up to butane from a lighter. What's happening? Bigger. More CO2 released. More CO2 released. Now, let me tell you this. Gasoline, diesel fuel, all those are huge carbon chains, like C22, C30 something. I mean, they're big, big carbon chains. So, let me ask you another question. If you look at the product side of all of these combustion of hydrocarbon equations, which substance there is something that we hear about currently as a gas of concern environmentally? CO2. So, when you burn hydrocarbons, you release CO2. You can't help it. That's just, it's the nature of the beast. The larger the carbons, the larger the hydrocarbon you're burning, the more complicated it is, the more CO2 you're releasing. So have you heard of CNG vehicles?
No.
Okay, compressed natural gas. So when you get, now propane at room temperature is a gas. Do you all know that?
Yes.
How many of you have ever picked up a propane canister for the grill or something? Okay. If you have not, I think this is homework for you. You should go to somebody's house who has a propane grill and ask them if you can move their canister around a little bit, because I want you to feel what it feels like. They're heavy. If you jiggle it, does it sound like it's gas in there?
Nope.
No. No.
Oh,
Well,
no,
I thought it was a gas at room temperature. So what's the deal? Why does it sound like it's a liquid in there? Why is it sloshy?
Because it is a liquid.
Well, how does that happen?
Oh, liquid gas.
Science.
Pressure. You pressurize that gas enough to make it a liquid. You can do the same thing with natural gas. You can compress it until it's a liquid and you can run a car on it. So let me ask you this. Running a car on compressed natural gas versus running it on gasoline or diesel, which is going to produce fewer moles of CO2 per unit of fuel used? The compressed natural gas. And they're not completely liquid cow farts, but, you know.
Could we try?
So,
Ew, this sounds gross.
well, now, interestingly enough, speaking of methane, are you all aware that landfills, where they bury trash, produce methane? Did you know that? Okay, so how How many of you have ever been to a landfill on a field trip? One or two?
I've been there.
Actually, no, a lot of elementary, like science classes, will go to a sanitary
I've
landfill.
just been there.
Okay. Well, okay, let me back up to something more applicable. How many of you have ever seen roadkill?
Oh yeah.
Okay, good. So, you've seen that raccoon laying in the middle of Route 7? On the day it gets hit, it looks like this. What does it look like several days later? Okay, it's a raccoon balloon. Why is it a raccoon balloon?
You think it exploded?
Sadly, yes.
I've always
Pressure.
wanted to, like, poke it with a stick.
Stop. So, why is it a raccoon balloon? There's a bunch of gas in there. There's gas trapped inside the raccoon balloon. So, that gas is generated by little bacteria that are decaying the raccoon from the inside out. All warm-blooded organisms carry the toolkit for their own chemical dismantling within their gut.
So it's like
It's a profound statement. So do you. Yeah, the bacteria in your body, at the point when you cease functioning as a living organism, start converting your body to little small organic compounds. It's fascinating stuff. So yeah, that raccoon balloon is being decomposed from the inside out, and those little bacteria are farting out methane and other gases, and they're filling up the raccoon balloon. So, a landfill has got all kinds of decomposing organic matter. People put grass clippings, which they shouldn't, and coffee grounds, which they shouldn't, and eggshells and banana peels and, bits of meat and whatever else into the landfill where they decompose. And, well, they don't really decompose in a landfill, but that's a whole separate matter. But enough stuff will start to decompose that you get methane coming off the landfill. So, what we used to do is we just vented that stuff to the outside and burned it off. Woohoo!
Done.
It is dumb, because you know what?
I said done.
Oh, done. Yes, it is dumb, but it's done, but it's also dumb. Done and stupid. So dumb and done and dumb. There we go.
Dumb and dumb.
Dumb and done. If you go up Route 7 to Boardman, go to the mall, hang an east, head out towards the PA line on 224, go through Poland, go all the way out on 224 until you could pretty much spit and hit Pennsylvania, and you're going to see on the south side of the road there a bunch of landfill space. It's the carbon limestone landstone. It's one of the places in Ohio where they've been experimenting with burning that methane off and producing electricity with it. You're going to vent it to the atmosphere anyway or burn it off anyway. You might as well get something out of that combustion reaction. You might as well get the energy out of it. So things to think about. Knowing the chemistry behind it, I think, makes the environmental issues a lot more approachable. So don't attempt to vent and burn the gases from the raccoon balloon, but methane is something that is being used as an energy source now. And I can guarantee you that come your test, come combustion, you're going to see some combustion of hydrocarbon questions and have to balance them. Whee! So, now these are all combustion of hydrocarbons. They're a very specific subset. Let's look at a combustion reaction that is also a synthesis reaction. So let me get rid of my hydrocarbons here. Magnesium! How many of you have heard of magnesium? Okay, it's a metal. It runs all by itself. It's a metal. We have some magnesium ribbon back here you'll be using a little bit later. If we combine magnesium metal with oxygen in a combustion reaction, we get magnesium oxide. And magnesium burns brighter and hotter than anything else. I'll tell you about thermite reactions in a little bit. So this is a combustion reaction. What other kind of reaction is it? It's also synthesis. So we can remember, they can belong to more than one category. Okay, questions, comments on combustion reactions? Okay.